For many of us, living in an 8-planet solar system is a fundamental pillar in our scientific knowledge. With Pluto having been demoted to a dwarf planet in 2006, Neptune is the last planet to have been discovered in our solar system. Neptune was first observed with a telescope in 1846, and since then there's been widespread discussion about whether or not there's another planet beyond it. This hypothetical planet is what astronomers refer to as Planet X. But could Planet X really exist? Discovering a 9th planet in our solar system almost 2 centuries after the last discovery may seem far-fetched, but it's actually way more likely than you might think. In fact, the existence of Planet X would account for a lot of anomalies that scientists have noticed, such as the seemingly erroneous orbits of some trans-Neptunian objects, or TNOs. Let's dig a little deeper. The story of how Neptune was discovered can provide some important insight into the possible existence of Planet X. Neptune is not visible to the naked eye, having only been observed via telescope for the first time in 1846. Uranus had been discovered in 1781, and in the interim, calculations had been made about its orbit. Astronomical tables calculating the orbit of Uranus were published in 1821 using Newton's laws, which is the scientific standard. Using these, one could presumably reliably pinpoint the position of Uranus at any given time in the future. However, there was a problem. Subsequent observations of Uranus showed deviations in its orbit, which seemed to defy Newton's laws. There were few reasons for this that we could explain. It was possible that the effect of the Sun's gravity differed from Newton's description when the colossal distance between it and Uranus was taken into account. It was also possible that the error had been made in observation. The third possibility, however, was that Uranus's orbit was being altered or perturbed by another gravitational body. As we now know, subsequent searching led to the discovery of Neptune and the understanding that it had in fact been affecting Uranus's orbit. Neptune has 17 times the mass of Earth and is also denser than Uranus, despite Uranus's larger diameter. But what does this mean for Planet X? Well, even before the discovery of Neptune, there was a debate within the scientific community about whether or not one planet alone could cause the discrepancy in the Uranian orbit. A German astronomer and director of the Gotha Observatory at the time is reported to have hypothesized as early as 1934 that one planet would not have sufficient gravitational pull to explain the motions of Uranus, and conjectured that there must be 2 planets beyond Uranus. After the discovery of Neptune, there was still widespread speculation about the existence of a further planet. In 1848, French physicist Jacques Babinet hypothesized that there was a planet with 12 times the mass of Earth beyond Neptune, which he referred to as Hyperion. Scottish astronomer George Forbes calculated that there must be 2 trans-Neptunian planets, based on the study of the paths of several comets conducted by Camille Flammarion in 1879. By the turn of the 20th century, William Henry Pickering, former director of the Harvard College Observatory, was leading 2 searches for trans-Neptunian planets. However, both searches came up empty-handed. Does this mean that Planet X simply doesn't exist? The fact that we haven't yet found a 9th planet doesn't necessarily mean that it's not out there, though. It's possible that we just haven't made the technological advancements necessary to see it yet. Remember, Neptune isn't visible to the naked eye. Although it has brightened since 1980 with a now average apparent magnitude of 7.78, it's still easily outshone by multiple celestial bodies, including Jupiter's Galilean moons, the dwarf planet Ceres, and even several asteroids, specifically 4 Vesta, 2 Pallas, 7 Iris, 3 Juno, and 6 Hebe. Until the invention of the famous Hubble Space Telescope, it was a challenge to observe Neptune even with a telescope. Now, with advances in telescopic recording and other technology, it's easier to visualize Neptune. But even now, some of the best footage we have of Neptune, such as this false color image taken from Voyager 2 in 1996, leaves a lot to be desired with regards to exact details. With an average distance of 4.5 billion kilometers from the Sun, Neptune is simply too far away for us to garner much information about it at all. It's for that reason that it's easy to see how another planet even further away could still be evading us. Now, you might be asking, what about Pluto? True, Pluto is even further away than Neptune and yet has been observed since 1930. In fact, at this time, it was even believed to be Planet X. But the discovery of Pluto was a stroke of luck. Clyde Tombaugh, a Kansas farm boy, had been serendipitously handed the job of locating Planet X at the Lowell Observatory, replacing Percival Lowell, who was widely known for his dedication to finding Planet X all the way up to his death. Taking photos of patches of the night sky 2 weeks apart, he tracked the entire zodiac. Then, by chance, in January of 1930, 2 of his photos of Gemini detected movement. This breakthrough led to the discovery of Pluto, which he named in honor of Lowell. Ultimately, it transpired that Pluto did not have the gravitational pull necessary to be the planet they were actually looking for, but it renewed hope that another planet could be found with the right technology and the right timing. We're still discovering TNOs in this century, such as Eris, and with each improvement of technology we come closer and closer to settling this case. However, there are other explanations that scientists have been investigating for these several orbital discrepancies. Scientists from the University of Cambridge and the American University of Beirut published their theory in 2019 that the unusual orbits of TNOs can be explained by their combined gravitational force as they orbit the Sun, as opposed to the existence of a 9th planet beyond Neptune. They proposed there could be a disk made up of smaller, icy TNOs, and that these together could constitute a mass up to 10 times the size of Earth's. If true, this is a game changer for how scientists have been pursuing the questions about the unusual orbits of these exoplanets, and could be a nail in the coffin for Planet X. There's more that could disprove the theory of the 9th planet, though. Voyager 2's space mission flyby of Neptune in 1989 reassessed the mass of the giant planet, and subsequent calculations put it at 0.5% less than previously thought. Though seemingly a minuscule percentage, it made a massive difference. In actuality, Neptune's mass was more comparable to that of Mars, and when that fact is taken into account, the anomalies in Uranus's orbit practically disappear. The readjusted mass of Neptune explains why Uranus's orbit seemed erroneous, and explains away the scientific need for a 9th planet to exist. This is why many scientists today have reached a consensus that if a 9th planet does exist, it's not the one that scientists of the 20th century expected. But does this mean the end for any hopes of discovering another planet out there? Not quite. Just because there is no longer any evidence pointing to a giant planet close enough to alter the orbits of Neptune and Uranus doesn't mean that there isn't another planet further out. Like we said before, Neptune is so far away that we don't have the technology yet to get a clear picture of it, so it's not beyond the imagination that a planet could exist beyond it with an orbit so vast that we haven't managed to track it down yet. And there is still evidence to support this idea. Take the orbit of the planetoid Sedna, a TNO that was discovered in 2003. Its orbit is incredibly erratic and cannot be explained by any gravitational body we've observed thus far. While some theories proposed are that its orbit has been affected by the gravitational pull of an undiscovered star, other theories propose that the gravitational pull of a distant giant planet could explain it too. However, while Mike Brown, the astronomer who discovered Sedna, has stated that the balance of probabilities lies with there being another planet beyond Neptune, that it's unlikely the planet would achieve anything beyond dwarf planet status due to the amount of uncleared planetoids and gravitational objects in its vicinity. Is there a Planet X out there? While the jury is still out on what exactly is out there, we can say for certain that with the advancements we've been making in technology and with the determination of astronomers worldwide, someday we'll find out. The New Horizons probe that flew by Pluto in 2015 didn't detect any large unknown planets on its journey, but it did capture the surface and secrets of Pluto like we've never seen before. Click here to see exactly what New Horizons discovered on the surface of Pluto. Thanks for watching, Elder Fox. Remember to subscribe and hit the bell to keep up to date with the latest discoveries.